Hello students, welcome to the fourth part of the application. Myself, Shankhu Ghosh, Assistant Professor of Automobile Engineering Department at Dr. Sudhir Chandra Sur Degree Engineering College under the JIS group. Today we will discuss on the fourth part of the application which was taken from the module number 11, that is Common Application NDT. Common application of NDT. This topic is taken from the subject of non-destructive testing and application. This subject is collect from the syllabus of 7th semester automobile engineering students. 7th semester automobile engineering student, and the subject code is AUE 705A. In the previous classes we discussed about the application of NDT, and now today we complete this session on so student, in the previous section we discussed the rail inspection, liberty bell inspection, liberty bell inspection, pipeline inspection, tank inspection, and now today we will discuss on the two types of this inspection. So students, let's start the today's class, that is the fourth part of the application. As I told, in the previous classes of this NDT, we already discussed or covered the various types of NDT methods, their procedure, their application, and their limitation, and we also covered the limitation, benefits and the limitation. And in this section we already discussed the application. In the previous three classes we already covered the application in rail inspection, liberty bell inspection, wire rope inspection, tank inspection, pipeline inspection. And today we will discuss on this bridge inspection and the aerospace industry inspection. Among these 7 inspections, there are NDT methods are used in the various fields. It is basically used for the production to maintenance or the service to check the quality purpose. And here we discuss only few of these things. So student, let's just start with this inspection. At first, start with the bridge. A bridge is a structure which is built to span a physical obstacle. A bridge is a structure which is built to span a physical obstacle, such as body of water, valley, or road, without closing the way underneath. It is constructed for the purpose. It is constructed for the purpose of providing the passenger over the obstacle. Usually, sometimes that can be determined to cross the otherwise. There are many different designs that each serve a particular purpose and apply to different situations. A design of bridge vary depending on the function of the bridge, the nature of the terrain where the bridge is constructed, and anchor, the material used to make it, and the fund available to build it. Most likely the earlier bridges were fallen trees and stepping stones, while Neolithic people built boardwalk bridge across the marshland. The Arcadico bridge, dating from the 13th century BC in the Peloponnese in southern Greece, is one of the oldest arc bridge still is existing and uses. So students, there are the number of bridges. There are the number of bridges. You can see the country. As I discussed in US, so it has it has 5,78,000 highway bridge, which are the lifeline of US commerce. The average lifespan of highway bridge is about 70 years, and the majority of bridge currently in use were built after the 1945. So, however, significant environmental damage require repair. Typically, which occurs before the average bridge reaches the midline. Corrosion, cracking, and the other damage. Can all affect a bridge load. Which is carrying the capacity. Therefore, all of the elements that directly affect performance of the bridge. The performance of the bridge, including the footing, substructure, deck, and the superstructure, must be periodically inspected or monitored. Visual inspection is the primary non-destructive execution method, which is used to evaluate the condition of the majority of the nation's highway bridge. The inspectors periodically pay each bridge a visit to assess its condition. Periodically means is about to every 2 years. However, it is not uncommon. For a fisherman, canoeist, and other passerby to alert official to measure damage that may have occurred in between the inspection. The potential penalties for ineffective inspection of the bridge. Can be very severe. Instance of major bridge collapse are very rare, but the results are truly catastrophic. The collapse of the Silver Bridge in the year of 1967 resulted in loss of 47 lives. The Silver Bridge is connected Point Pleasant, which is West Virginia, and connected to the Gallipolis, which is Ohio, over the Ohio River. So this Silver Bridge is connected with the Point Pleasant of West Virginia to the Gallipolis of Ohio which is over the Ohio River, is collapsed. Was collapsed in the year of 1967, and that resulted in loss of 47 lives. The cost of the disaster was this disaster was $175 million, but some experts estimate the same occurrence today could cost in between 2.1 and 5.6 billion dollars. The cost of this disaster, that means the collapse of the Silver Bridge, was $175 million, but some expert estimate the same occurrence in today's world. It would cost 2.1 to 5.6 billion dollars. Furthermore, these cost figures do not take into account. This cost of figure do not take into account of factor such as loss of business resulting from loss of access or debtors. The cost resulting from the blockage of a major river shipping channel and potential environmental damage due to the hazardous material being transported over the bridge at the time of the collapse. Here is the picture of the Silver Bridge after the collapse. The consequence of ineffective bridge inspection are usually not as severe as those at the Silver Bridge. However, repair and retrofit costs on bridge represent a very significant portion of a state's transportation budget. In the future, replacement of a bridge will become an increasingly unattractive alternative. Growing construction costs, increased losses due to traffic, growing construction costs and increase the losses due to the traffic disruption during repair or the replacement, and continuing tight budget will force the life extension to be the only viable alternative for our aging bridges. Fatigue crack and the corrosion will become increasingly important consideration as we go beyond the 75 years life expectancy, and current visual inspection techniques will not be sufficient. The life extension approach will require increased the use of NDT in a coordinated effort to obtain the reliability assured for this structure. The life extension approach will require the increased use of non-destructive execution in a coordinated effort to obtain the reliability assurance for this structure. The NDTE techniques such as magnetic particle inspection and the ultrasonic inspection are being used with a greater frequency. One of the newer NDE technology being used is acoustic emission monitoring, or AE. Some bridges are being fitted with AE instrument. Some bridges are being fitted with the AE instruments, and then listen to the sound that a bridge makes, and it listen the sound that the bridge makes. This sophisticated system can detect this sophisticated system can detect the sound energy which is produced when a crack grows and alert the inspector to the crack presence. Sensors can be permanently fixed. The sensors can be permanently fixed to the bridge and the data transmitted back to the lab so that continuous bridge condition monitoring is possible. So that the continuous bridge condition monitoring is possible. Here the image which is provided here show the field engineering installing an AE monitoring system on the lift cable of the Ben Franklin Bridge in the Philadelphia, PA. So in this way we can easily fix up the AE monitoring system on the bridge. So we can easily analyze the defect or is there any problem or not on bridges. So after complete the bridge inspection, now coming to the next one, that is the aerospace industry inspection. Next one is aerospace industry inspection. Before starting the aerospace industry inspection, let's discuss on the aerospace. Aerospace means is human effort. Aerospace means is the human effort in science, science, engineering, and business to fly in the atmosphere of Earth and surrounding the space. Aerospace organization research, design, manufacture, operate, or maintaining the aircraft or the spacecraft. Basically, the aerospace activity is very diverse with a multitude of commercial, industrial, and the military application. The aerospace is not in the same as the airspace, which is the physical airspace directly above a location on the ground. The being of space and the ending of the air is considered as 100 km above. Considered as 100 km above the ground, according to the physical explanation that the air pressure is too low for a lifting body to generate the meaningful lift force without exceeding the orbital velocity. In the most industrial country, the aerospace industry is a cooperation of the public and the private sectors. For an example, several states have a civilian space program which is funded by the government through tax collection, such as National Aeronautic and Space Administration in the US, European Space Agency in Europe, and the Canadian Space Agency in Canada. Indian Space Research Organization or ISRO in India. Japan Aerospace Exploration Agency in Japan. Roscosmos State Corporation of Space Activity in Russia. China National Space Administration in China. Superco in Pakistan, Iranian Space Agency in Iran, and Korean Aerospace Research Institute in South Korea. Along with this public space program, many companies produce technical tools and components such as spaceship and the satellite. Some known companies involved, some known companies involved in the space program include Boeing, Qualcomm, Airbus, SpaceX, Lockheed Martin, United Technology, McDonnell Douglas, Lockheed Martin. These companies are also be involved in the area of aerospace in such as the construction of the aircraft. So, students, in this aerospace industry, as with other transportation industry, aerospace industry as with other transportation industry, NDT can make the difference between life and death. NDT can make the difference in between the life and the death. The aircraft components are inspected before they are assembled. Aircraft components are inspected before they are assembled into the aircraft, and then they are periodically inspected throughout their useful life. The aircraft parts are designed to be as light as possible while still performing their intended function. This generally means that components carry very high load relative to their material strength and small flaw, which flaws it can cause a component to fail. Since aircraft are cycle loaded or unloaded as they fly, land, taxi and the pressurize the cabin. Many components fly, land, taxi and the pressurize the cabin. Many components are prone to fatigue cracking after some length of time. If you are unfamiliar with the term, the fatigue cracking, think about what happens when you bend a paper clip or a piece of wire back and forth. Eventually it will break. So students, if you forgot or if you cannot understand about the term that is the fatigue cracking, you just take a paper or a wire in your hand and you start to bend sorry I mean students will take a paper clip or a piece of wire, and now you start to bend this paper clip or the piece of wire back and forth. Eventually after some time it will break, and this is called fatigue cracking. Even parts that are loaded well below the level that causes them to perform can develop fatigue cracks after being cycled for a long time. This is after a long time. This is what happens in aircraft. After they are used for a while, fatigue cracks start growing. The fatigue cracks start growing in some of their parts, and cracking can also occur. And the cracking can also occur due to the other things like a lightning strike, like a lightning Strike. Aircraft have some protection against the aircraft have some protection against the lightning strike, but occasionally they occur and can result in crack forming at the strike location, like the one shown in the strike location. Another problem that aircraft is that they are under the constant attack of fraction, attack of corrosion. Beside the fatigue problem, there is another problem that aircraft have is that they are under the constant attack of corrosion. When an aircraft land, the door is open, the inside of the plane often fills with warm moist air. When the plane takes flight and reaches altitude, the skin of the aircraft becomes very cold. The skin of the aircraft becomes very cold due to the temperature of the outside air, and this causes the moisture held by the air inside the cabin to condense on the inside of the aircraft skin. The water will collect at low area. The water will collect in the low area and serve as the electrolyte needed for the corrosion to occur. The good news is that the aircraft are designed to withstand a certain amount of damage from cracking and corrosion without causes for concern. The NDT inspector are trained to find the damage before it becomes a major problem. The rigorous process used to design the aircraft either allow for a certain amount of damage to occur before a part fail, or in many cases a part can fail completely and performance of the aircraft will not be affected. The job of the NDT inspector is to find the damage while it is within the acceptable limits. Over 80% of the inspection over 80% of the inspection done to an aircraft are visual inspection. At regular interval, inspectors look at the various components of the aircraft for sign of damage. During heavy maintenance work, much of the interior of the aircraft is stripped out, so inspectors can look for damage on the inside surface of the fuselage. However, not all area of the aircraft can be accessed for the visual inspection, and not all damages can be detected by the visual means. This is where NDT play a critical role in thoroughly inspect the airplane. The NDT method allows inspector to inspect areas of the plane that would otherwise be uninspectable without disassembling construction to gain access to the internal area. The NDT method also allows the inspector to detect the damage. The NDT method also allows the inspector to detect the damage that is too small to be detected by the visual news. The AD current and the ultrasonic inspection, the AD current and the ultrasonic inspection methods are used extensively to locate tiny crack and that would otherwise be undetectable. These techniques are also used to measure the thickness of the aircraft skin from the outside and detect metal thinning from the corrosion on the inside surface of the skin. X-ray techniques are used. The X-ray techniques are used to find the defect buried deep within the structure and to locate the area where the water was penetrated into certain structure. And obviously, these tasks require the trained professional who are capable of performing a variety of different NDT techniques to get a complete and accurate status of the airplane. There is no question that the success, there is no questions that the success of the airplane industry is depend on NDT. The success of the airplane industry is depend on NDT. Without NDT, the cost of maintaining and the flying, without NDT and the cost of maintaining and the flying in airplanes would increase dramatically, while the safety of flying would decrease, When the people step into airplane, they trust that it will get them to their destination. With as little turbulence as possible. So for this purpose, NDT plays a vital role in keeping air travel one of the safest mode of the transportation. So students, this is the various types of application we already discussed. So students, you can see here is a picture of number of words. Here all the words those are written in this picture, all of are is connected directly or indirectly with the NDT or non-destructive testing, such as eddy current, quality, porosity, case depth, automation, surface quantity, superficial hardness, case depth, flaw verifications, cracks, quality probes, safety, flaws verification, defect detection, polish, crack treatments, material mix, heat treatment, safety, etc. So this picture is say about the application of NDT. So students, here we complete the application of NDT. So after completing, you can easily understand about the various kinds of application where we use this NDT techniques and how this NDT technique is used for the rail inspection. You can easily understand about the how the NDT technique is used to inspect the Liberty Bell inspection, how NDT is used, how is NDT used for to inspect the pipeline, to inspect the bridge, to inspect the aerospace industry, to inspect the wardrobe. So after this we can easily understand about this the inspection methods. So this is the application. So the next class we will discuss. So student, this is the application process, and the next class we discuss on a new topic. So still then, stay at home and stay safe. Thank you so much students.